So hi and hello. Welcome to our channel named Algo Exploration. My name is Sameer and today we will going to learn about counting sort. Now till now we have seen in the sorting series bubble sort, merge sort, quick sort, selection sort and insertion sort. All these sorting techniques have an interesting property, that is they are sorted based on comparison. So due to this it is also called as a comparison sort. Right now, due to this there is also another way to sort the data, which is called as a non-comparison sort technique, which includes counting sort, radix sort and bucket sort. We will learn this one by one, but let's start with counting sort first. So this will be the counting sort. So now counting sort works relatively on small range of numbers. It actually doesn't rely on comparison, right? And it deals with the frequency of occurrences of the element. Let me show you how. Now this will be our array. Now our first step is we have to find the minimum and maximum element. The minimum element is 1 here and the maximum element is 8, right? So let me write it. Max element is 8 and minimum element is 1. Now we have to make an auxiliary array of size max minus min plus 1. So let's define the size. Here max is 8, min is 1 plus 1, that will be 8. So we have to make an array of size 8. So this will be our array of size 8 starting from 0 to 7. Now we have to count the frequency of each element present in an original array. So we have to iterate through the input array and count the frequency. Let's find the frequency of each element. Now the occurrences of 0 is actually 0 only. The occurrence of 1 is 1, right? The occurrence of 2 is 2. The occurrence of 3 is also 2, right? The occurrence of 4 will be only 1 here, so let's write it 1. The occurrence of 5, there is no 5 here, so 0. Occurrence of 6 is 0. Occurrence of 7 is also 0, and occurrence of 8 is 1 here, right? Now we have calculated all the occurrence of the element. Now we have to store it in array C, that is an auxiliary array. Now focus here. In cell C of 0, occurrence of 1 will be present, because as we know that array index starts with 0. In C of 1, occurrence of element 2 will be present. In C of 2, occurrence of 3 will be present, and so on. And in C of 7, occurrence of 8 will be present. Let me write it all. And 7. Now occurrence of 1 is 1, occurrence of 2 is 2, occurrence of 3 is also 2, occurrence of 4 is also 1, occurrence of 5 is actually 0, occurrence of 6 is 0, occurrence of 7 is also 0, and occurrence of 8 is 1. Now our third step is complete, that we have to count the frequency of every element. Now the fourth step is we have to calculate the cumulative frequency, that is the formula will be Ci equals to Ci plus Ci minus 1, right? This is our C array. Now our first input will be 1 only, our first element will be 1 only. Now we have to add this element with this element and put it here, that will be 3. So due to this, Ci equals to Ci plus Ci minus 1. So C of 1 plus C of 0, that will be 3. Similarly here 2 plus 3, that will be 5. Now this will be 1 plus 5, that will be 6. Here 0 plus 6 will be 6. This will also be 6. This will also be 6. And this will be 7. 1 plus 6. Now we have calculated the cumulative frequency and store it in array C. This is actually in case only that we are computing all the operations in array C only. Now our final step is build an array. Now this is the most important step, so focus here carefully. What we have to do, we have to come from the last index, take the element that is 1. Now we have to do minus 1 because the array starts with index 0. So this will be 1 minus 1, that will be 0. So we have to go at C of 0 and take the element from C of 0 and do minus 1 also. That will be 0, 1 minus 1 will be 0, and go to B of 0 and put 1 here. Where did this 1 came from? It came from this one. Okay, I hope you got this. Now let's come here at A of 5. Take the element that is 3 and do minus 1, that will be 2. So go to C of 2. Take the element from here, that will be 5, and do minus 1, that will be 4. So go to B of 4 and put 3 here. And the extra step is we have to do, that is decrement this value by minus 1. So that will be 4. Right. Now come at A of 4. Take the element that is 3, go to C of 2 because 3 minus 1, that will be 2. Now at C of 2, 4 is present. So do minus 1 here, that will be 3 here, and then go to B of 3, right, and put 3 here, right, and do minus 1, that will be 3. Now go to A of 3, take that element that is 8, do minus 1, that will be 7, go at C of 7, okay. Take the element from here also, do minus 1, and that will be 6, go to B of 6 and put 8 here and do minus 1, that will be 6. Okay, now let's go to at A of 2, take the element 2, do minus 1, that will be 1, go to C of 3, take the element that will be 3, do minus 1, that will be 2, go to B of 2 and put here 2 and do minus 1, that will be 2 here. Now we will be at A of 1, take the element A of 1, that will be 2, do minus 1, and that will be 1, come at C of 1, the value present here is 2, do minus 1, that will be 1, so come at B of 1, put 2 here and do minus 1 also. Now we are at A of 0, take the element that will be 4, do minus 1, that will be 3, go at C of 3, here the element is 6, do minus 1, that will be 5, go at B of 5 and put here 4 and do minus 1 here. Now we will be here, it is actually out of bound, so we will come out of the loop. So this will be our final array, and we can see that all the elements are being sorted. So without doing any comparison, we get the sorted array. So in this way counting sort works. This will be the pseudocode. Here I have named the function as counting sort, which takes the parameter original array p and the output array and the value k. Here k is actually the range, right? Now here we have to create an auxiliary array named as C of size k plus 1, 0 to k. Then we have to fill it with 0 element. All the elements in an array C will be 0. This will take n time. Now here we have to create the count frequency of an element present in an original array. This will also take n time, right? Now this is the cumulative array. Right, this will also take n time, and we have seen the formula C of I equals to C of I plus C of I minus 1. Right, now this will be the step where we build an array. We will take A of j value. Let's assume that value is x. Then we will go at C of x. Let's assume it y, and we will go at b of y, and we put here x. So in this way we build an array, and after that we will decrement the y. So actually this is a tricky part, but you have to try run it so that you will understand. So here also the time taken will be n, that will be n plus n plus n plus n, which is 4n, that is order of n. Now we can see that time complexity to sort an array using counting sort is actually order of n. But we know that the merge sort and quick sort, which is the efficient sorting algorithm, takes n log n time, and counting sort versus this merge sort and quick sort, in which counting sort wins. But here there is one drawback, that is we have to know the range. What if the range starting from 0 and goes till 10 raised to 8, and the element present are only, let's say, 10. So for this 10 element, the auxiliary array we have to build will be 0 to 10 raised to 8, which is quite huge. So due to this drawback, we go for merge sort and quick sort. But when the data is limited, we go for counting sort. So I hope you got this algorithm. Now there is another approach to solve this, that is also counting sort only. Let's try run it together. This is an original array, this will be the count frequency array, and this will be our final array that we have to build it. Now focus here. Initially k will be 0, I will be 0, and c of I, that is c of 0, is 1, right? C of 0 is 1, and j will be running from 0 to 0 because this will be exclusive. Now what we are doing, we are putting I plus 1 value in b of k, and we will be incrementing k after that. Now at b of 0, we will be putting I plus 1, that will be 1 here. Now we will be incrementing k to 1, and since j is running from 0 to 0, therefore it will be running only one time. Now let's increment the I, that will be 1. Now c of 1 is actually 2, so j will be running from 0 to 2, therefore 2 times, because 2 will be exclusive. So 0 to 1. So initially j will be 0. What we are doing, we are putting I plus 1 in b of 1. I plus 1, I is actually 1 here. 1 plus 1 will be 2, and we will increment the k, that will be 2 now. J will be 1, right? And we will be putting I plus 1 in b of 2, that will be 2. Let's increment the k as well, that will be 3 now. Now this for loop will be terminated, so let's increment the value of I, that will be 2. C of 2 is also 2. Let's put 2 here. J will be running from 0 to 2, that will be 0 and 1. Now initially j will be 0, so let's put I plus 1 in k of 3. So I is 2, 2 plus 1 will be 3. Let's put 3 here and increment the k, that will be 4 now. Now j will be 1 here. Let's put I plus 1 in b of 4, that will be 3 here again, and increment the value of k. This will be terminated. Let's increment the value of I, that will be 3 now. C of 3 is 1, so j will be running from 0 to 0. Initially j will be 0 now. Now what we will do, we will put I plus 1, that will be 3 plus 1, 4 in b of 5, right? So this will be terminated. Let's increment the value of I, that will be 4 now. At c of 4, 0 element present, so j will be running from 0 to -1, which will not happen. Let's increment the value of I, that will be 5. Also c of I is 0, so this will not happen. Increment the value of I, that will be 6. It is also containing 0, this will not happen. increment the value of I, that will be 7. At C of 7, 1 is present, so J will be running from 0 to 0. Initially it will be 0, now A is actually 6. At B of 6, 7 plus 1 should be present, that will be 8. So let's put 8 here, and we can see that the resultant array is being sorted. So this is also another approach, but I think this one is actually simpler one than this. Okay, now this will be the first part, and the time complexity and the space complexity will be the homework for you. Now my next question is, what if the elements are negative in an original array? Try to think about. I will be coming with the solution in the next video. So thank you.